Okay, we're going to take a look at binomial settings. So there's two of them that we're going to deal with: binomial settings and geometric settings. So binomial setting is, in its simplest terms, I'm going to have a fixed number of trials, and I'm going to count the number of successes. So basically what it's going to say is, say I'm flipping a coin. There's a success or there's a failure. So that's the first thing. There's binary result, two results. The next is that they're independent of one another, that one result has no impact on the next result. The next one is I have a fixed number of trials. And the last one is that probality of success remains constant through the whole process. So we're going to go ahead and take a look at an example and see if we can figure out if this is a binomial setting. Easy for me to say. Okay, so for each of the following situations to determine whether or not it's a binomial distribution. So here's what we got. You play a game of whack-a-mole. From playing this game in the past, you know that you have an 80% probability of whacking the mole before it drops back in this hole. The moles pop up randomly, and your ability to whack any particular mole is not affected by whether or not you whacked the previous mole. There are 20 moles to be whacked during one round of the game. Let X be the number of moles you are able to whack. So in this case, the question is it binary? And the answer to that is, yeah, it's binary. Yes, because you either hit or you miss. So there's two options here. You either hit or you miss. You whack it or you don't. The next one, is it independent? Well, from the words of this problem, if we look at it, there is a level of independence. And so the case right here, it says your ability to whack your mole is not affected by whether or not you whack the previous mole. What it's saying is, whether or not you hit the first time or misses, it has no bearing. So in this case, it is independent. So in this case, what it's saying is, yes, it's independent because each try is not impacted by other tries. Okay. The next thing we're looking at is the number of trials fixed? So is our number of trials fixed? And in this case, the answer again is yes, because it says there are 20 moles to be whacked. There are 20 moles to be whacked. So we know in this case that our n is 20. So yeah, in this case, it is a fixed number of trials. And then S says, do I have the same probability of success? The same probability of success on each trial. And according to this, if I look, it says you have an 80% probability of whacking the mole. So in this case, yes, it is. We are true because, yes, because the probability is equal to 0.80. So in this case, this is a binomial setting. This is a binomial distribution. So this is a binomial. Yeah, it's a binomial because we hit all four of the bins, B-I-N-S. Okay. Next one says, next you play skee ball. You know that you have a 10% probability of getting any given ball in a 10,000 point hole. Let Y be the number of balls you must roll until you get one into the 10,000 point hole. So if we go through the same idea of the B for binary, it is binary because it is either in the 10,000 or not in the 10,000. So in this case, again, we are binary. Is it independent? Well, in this case, we're going to make the assumption that it's that one roll has no bearing on the other one, kind of like what we said before. It doesn't say it, but we're going to make the assumption. We're going to assume that one roll doesn't impact others. N, fixed number of trials. Well, this is not a case. This one right here, we don't meet the N part because we could actually have, hang on one moment. Okay, back to it. We don't know if you make it on the first one, the second one, the third one, the fourth one, the fifth one. It could be any number. So in this case, it's not a fixed number of trials. It's not a fixed number of trials. So this is not binomial. Okay, it's not binomial because of that. So the next one says, we're going to go back to Tsunami Duck Pond. In Tsunami Duck Pond, there are 100 ducks that get pummeled by tidal waves. This is a very dark game. You have to reach your hand into the tsunami and select the duck. If there's a star on the bottom of the duck, you win. The game claims to have 20 ducks with stars among the 100 ducks. After each round, you must place the duck back in the tumultuous water. Let W be the number of times you win if you play this game 10 times. So again, let's explain why it's binomial. First reason why it's binomial, binary, yes, because it's either a star or it's not a star. So it's binomial. Independent. Well, in this case, we're going to make some assumption of independence there. And the reason we can assume independence there is the duck is returned. We put the duck back in, so me taking one out doesn't change the probability, doesn't have any bearing on it. And fixed number of trials, yep, there's a fixed number of trials. That's going to be our n equal to 10, because we're playing it 10 times. And S, do we have that same probability? Well, it doesn't explicitly say the probability, but you can figure it out. Out of 100 ducks in this game, 20 are going to be winners, so that my probability of success is 0.20. So now, the next question says find the probability you will win exactly 3 times. So we want to say probability that W is exactly 3. So what we talked about in class is the following. When we deal with binomial settings, what we wanted to do is we want to win 3 times, but that means we are going to lose, that's what that 80% is, 7 times. And there are multiple different ways to win 3 times. And what we use is, it's this counter here that we're going to use. It's 10 choose 3. And what we talked about in class is this. What that 10 choose 3 means is it's 10 factorial over 3 factorial times 7 factorial. Now your calculator is going to do most of the heavy lifting here, but this is what this binomial number, this count that we use is. So 10 factorial is 10 times 9 times 8 times 7 times 6, 5, 4, 3, 2, 1. 7 factorial is 7, 6, 5, 4, 3, 2, 1. 3 factorial, 3, 2, 1. So what's going to happen is 7, 6, 5, 4, 3, 2, 1, 7, 6, 5, 4, 3, 2, 1. What this is going to be is it's going to be 10 times 9 times 8 over 3 times 2 times 1. So that's going to tell you the number of ways you could get 3 ducks. So again, remember, you get the first 3 ducks win and then lose 7. First duck, miss 2, get 1, miss 3. So there's so many different ways. This is, again, how we count it. So this right here is considered our work. And then what we're going to do is we're going to pick up our calculator. And the way we do it in our calculator is the following. We do second, vars. And what we're going to do is we're going to go find binomial setting. And what we're doing is binomial PDF is an exact. Binomial CDF is a range. So we're going to stick with binomial PDF because it's an exact number, binomial PDF. And it's going to ask us for arguments. It's going to say how many trials. Well, we're picking 10 ducks. What is my probability of success? Well, it's 0.2. There's 20 out of 100. And what's that exact value I'm looking for is 3. What this is going to do, when I paste this in, it's going to paste in as binomial PDF 10, comma 0.2, comma 3. This is my number of trials. This is my probability of success. This is that exact number I want. It's going to calculate what this number is. So when I hit enter on this, it's going to say 0.2013. So what this is telling me is that I have a roughly 20% chance, 0.2013 chance of winning exactly 3 times out of 10 trials. So that's the beginning of what we talked about in binomial setting. So I'm going to do another one where we're going to actually do a little bit more practice. We're going to go through this. So we'll do that in a separate video.